We work in very difficult conditions when you think about working on the surface of the moon or the surface of the planet Mars. Temperatures can be well below -50, and you need to have batteries and propulsion systems that work at those temperatures. And because we're faced with that problem of low temperatures, we end up making our batteries more efficient with techniques, and it's energy for size that we're after. And the collaboration between the space agency and the terrestrial companies that are interested in that kind of thing has profited from the Economic Action Plan, where we received $60 million to do that. It's the same thing for the challenge we have with communications. We have to sometimes have a 20-minute delay between the time you give a command from the Earth to the time you receive the information about what the rover is doing. Consequently, the rover has to work with tremendous autonomy. That autonomy has allowed us to build navigation, guidance, and control systems that work automatically, and that too is something that you're starting to see with the original equipment manufacturers, for example, in the Ford Fusion. So it's a combination of what we're doing in space, driven by the challenges of space, with what's required on the ground. Final one is the radiation environment that we're in is often tough, and consequently we need to build cards, like for example the cards that are in here that are much more robust for their size. This is a Cyphos Q6 card, and basically it's a very, very small computer that is versatile, that is at the heart of each of these rovers, and that allows you to do almost everything you need to do, and it can be programmed in a way that makes it incredibly efficient. This one is actually a sun sensor that we have here that would be used for locating where you are. So when you look at the component technologies, it isn't just the rovers that are impressive here, it's these component technologies, the cards, the fuel cell systems. In fact, Hydrogenics, which built a fuel cell system that drives the Lunar Exploration Light rover, it drives it completely, so you have now a complete vehicle working on a hydrogen-based fuel cell system. Hydrogenics just received a few days ago a $90 million contract based on these ideas to one of the original equipment manufacturers in the car industry. So at that component level, it's a big deal. The same with the SRL Commander. The batteries that we've developed together make it an efficient system. So it's across those components, all those components, where we're going to see an excellent metric with respect to what we're doing here. And on average, the Canadian Space Agency, for every dollar we invest, the return on our investment is about a factor of 12. Some years it's 8, some years it's 10, some years it's 12, but it has averaged out to about 12 over the last 20 years. And with work like this, we will continue in that perspective where we are stimulating the economy and creating jobs.